Dear ladies and gentlemen, I welcome you and I am pleased to present an innovative technology for flood risk analysis and communication, FloRiCiMo. Urban areas are subject to high development dynamics. In this context, they must develop resilience to extreme hydrological events in relation to climate change impacts. We are familiar with the images of flash floods and inundation, including those of flood defenses that lead to flooded basements, the entry of water, sediments and silt into buildings and, as a result, massive damage. People, buildings and infrastructure are at great risk during these hazardous periods, and decisions by crisis teams must be made in short time based on validated data and forecasts. Up-to-date, valid city data is also the basis for preventive risk analysis and communication. In prospect, we will not only have to manage flood exposure, but also develop concepts against impacts of water shortages in combination with rising temperatures. The digital transformation of the real city into a digital twin introduces a new dimension for a quality-assured digital workflow as well as an overarching data management scheme. Digital city models provide comprehensible and detailed temporal information about the exposure of buildings and infrastructure, and thus will become a central platform for planning, services and communication. The digital city model FloRiCiMo is an ideal platform for the coupled modeling and simulation of flooding scenarios in urban areas and their visualization. The central element is a VCS web portal created and hosted by the company Virtual City Systems. In FloRiCiMo, the city of Dresden was chosen as a pilot project and continuously transformed into a digital urban twin, augmented with hydrologically and hydronumerically relevant data. Furthermore, the web portal allows interactive data management for flood risk analysis. For example, data can be selected by category and location and subsequently exported in two required formats. The exported data is the basis for two-dimensional hydrodynamic numerical simulation models, which can be used to simulate a flood scenario for the desired location and to determine hazards. Major break lines, which are essential for the generation of computational measures and thus for the quality of the simulation results, can also be extracted directly from the digital city model. We deliberately have chosen an open approach to support multiple data formats in the extraction process, so that simulation models for many commonly used solvers such as HydroAS, HackRAS 2D, Mike21 or Basement can be created with minimal manual work in a short time. Large-scale 2D simulations for flood hazard analysis in urban areas are state-of-the-art. With the digital transformation in the field of civil engineering as well as increasing computational power, three-dimensional modeling and simulation becomes more prevalent. This is important because often a few centimeters decide about the flooding of underground floors, for instance, in underground garages or shopping centers. For this reason, the FloRiCiMo approach also enables the immediate generation of 3D models for runoff simulations by incorporating building information modeling. The results of the 2D hydronumerical simulation can be directly transferred as boundary conditions for 3D simulations of selected objects. After we have been able to determine the hydraulic hazards and impacts caused by floods using 2D or 3D hydronumerical simulations, it is now necessary to superimpose the hazard with the existing damage potentials. As a result, we can determine an event-specific risk for the areas under consideration. The digital twin also allows the integration and analysis of real-time data from external sources, such as current stream gauges. FloRiCiMo is an innovative, multifunctional and expandable technology that takes working with and communication of water topics to a whole new level for all urban actors.